Hey, how's it going, everybody? Michael, welcome back. Michael, and of course, Brian, good to see you again. Okay, well, wait a second. I'm not sure if there's something lagging or whatnot, but it says there's nobody here, but I can see people here, so that's confusing. It looks like people are starting to come in now. How are my little tofurkeys doing? That tofurkey, by the way, I don't know if you guys heard this, but the Linux Foundation actually just held a vote on what to refer to people that write OpenTofu, and tofurkey got first place. I'm kidding, of course. But yeah, we'll get started here in just a second. I think my camera's over here. That's fun. Sweet. So today we're going to do CI/CD integration with OpenTofu. So this is exciting for me today. So a couple of things. So we are going to introduce MassDriver just a little bit. We're not going to do like crazy vendor spam. We'll kind of get to it at the end and show how you can use MassDriver like beyond just using CI/CD. Yeah, so a little nervous about that. I hope you guys don't hate our product, but we'll jump into walls of YAML first and see how much everybody enjoys that part, because that's probably the most exciting. Is that spelled Tofuri? I like Tofuri. I like Tofuri. There's something else I really like about OpenTofu. The name really changes if you capitalize those last two letters. You know what I mean? Okie dokie. So we'll leave that as it is. Okay, so cool. I hope everybody's enjoyed the sessions so far. We've gotten a really good handle of like writing some OpenTofu, writing some HCL. And again, like, the whole goal of this workshop wasn't necessarily to make everybody AWS experts. It was to really get people familiar with OpenTofu, how to use it, how, your Terraform modules kind of just work with OpenTofu. And then we want to help people learn how to like start to integrate it into CI/CD pipelines. Like this is where my passion kind of lies, and what caused us to want to start MassDriver is we have seen so many companies over the years adopt infrastructure as code or like get started adopting infrastructure as code, then just get ground to a halt when they're trying to get it to that next level where like engineers are starting to use the Terraform and whatnot. And so today is exciting for me to like actually show like how you can start integrating these into your PR pipelines. I hope it's super useful for everybody here. But hey, Andreas, how's it going? But we'll go ahead and get going. So there's a lot of moving parts today. So unfortunately, like the scaling part of infrastructure as code, scaling it across humans and organizations is where the hardest part of IAC is, in my opinion. It's not learning HCL. It's not learning the command line. It's not even learning like how RDS works or EC2 works. It's literally how do we get this tool that is very ops-centric scaled across our entire organization and in the hands of developers where they can self-serve and do this stuff themselves without kind of shooting themselves in the foot. And so we're going to bounce around a lot today. We're going to see a couple different Git repos because we're going to start to really productionalize like the scale of our IAC, not the scale of our compute. And we'll kind of hop back and forth between code, some Git repos, and this presentation. So I'm just sharing my entire screen here. So if a weird text comes in from one of my family members, just ignore it. I think I have them turned off anyway. So let's get cracking. So first, what I want to do is kind of talk about what we're going to do today. So we're going to configure some state management. And so this is really key to starting to scale this across your org, is having state under management in some sort of remote storage engine. We're going to get really deep into state in the upcoming weeks. So today we're just going to touch enough that we can kind of walk through how to get CI/CD set up. Then we're going to look at how to organize our modules into different repos. We'll set up some GitHub actions, which, whoo, baby, you're going to end up with a lot of push and pray, just to let you know. And then finally, we'll talk about scaling IAC adoption with infrastructure automation platforms like MassDriver. So before we do all that, though, like let's talk about like what we're getting out of this IAC thing again. And I skipped too many slides ahead. So like when we hear people talk about infrastructure as code, these are the things that they're always saying, this is what you're going to get. With IAC, you're going to get reproducibility, consistency, version control, documentation. Like the story of what you get with IAC is so long and sounds so great. And so many people start getting into IAC, and what they find is they actually don't get most of these benefits. Because the reality is like just using something like Terraform or OpenTofu or even Pulumi or any of the IAC tools out there, you really just get the first three. And some of the other stuff kicks in. So like, what do we mean by each one of these? So like reproducibility, the ability to reproduce this infrastructure. Yes, you get this with OpenTofu. I've got some code. I can spit it out to 3 or 4 different environments. That's great. Consistency, again, I've got the same code that's enforcing these configurations. It keeps these environments nice and consistent. And then I can integrate it with something like GitHub or Bitbucket to get version control. Now, the rest of these features that you kind of hear about, you don't really get them with infrastructure as code. You get them when you start to integrate into CI/CD pipelines, or when you start to integrate into infrastructure automation platforms. So what I want to do is kind of talk through each one of these and like what you get and what that benefit is. So the documentation portion, like you kind of get it with Terraform, but it requires manual documentation. You have to use tools like Terraform docs and update your README, but it kind of excludes like the overall architecture of your system. Like you have a documentation around one module, but how does my entire cloud environment look? You don't know. Collaboration, like you get a little bit of this through like VCS and pull requests or version control system and pull requests. But you don't get that like rich interactive collaboration that you kind of hear that you get with IAC. Audit trails, again, you can't do this with Terraform itself or OpenTofu itself. It requires CI/CD integration. Rollbacks, another thing. It's like, oh, I can quickly roll back changes, right? The number one cause of outages today is misconfiguration, right? We're in a world of configuration in the cloud, and rolling things back, you can do it, but you have to do it through your VCS system. So it's like, it's not something that's necessarily in OpenTofu. It's like you have to stack on CI/CD to get there. And then some of the other functionality like change history, again, like it's very VCS version control system based. Automation, that's what we're going to be doing today. So you'll see how we kind of work through using GitHub Actions to start doing some of this automation. And then these last three is where it really just kind of, these last three are the ones that I feel like are the most exciting to the business about infrastructure as code, but are the ones that is the furthest away from, brew installing OpenTofu. And that is scalability, and not scalability in the sense of scaling your cloud. Like that comes down to the configuration of your resources. I'm talking about scaling IAC adoption, right? Standardized, reusable templates, automation that kind of abstracts the complexity away from the developers, lets teams use IAC without them like becoming an HCL guru, right? Like that doesn't kick in just the CLI at all. Like you have to have some additional tooling on top. Security and compliance is another one that people typically say, oh, we got to do IAC. It'll help us with our security and compliance. It does, but you have to throw on other tools like OPA and checkoff and TF scans. There's other things that got to get brought into it. And then I think the final one that I think, unfortunately, a lot of people kind of just bump their chin on is self-service, right? Like when we think about a lot of the operations tools that we have today, from Terraform to Pulumi to OpenTofu to even Kubernetes, I see these as operations tools for them to build a platform for their developers. But a lot of organizations kind of see it as a thing that developers use, right? And that's fine. It's exciting. Maybe you want to do it in your home lab, but like when you're spending 40 hours a week trying to ship features, having to think about how to do zones and databases and encryption and all this stuff, like it's just extra configuration that doesn't really matter to you as a developer who's just trying to ship something, right? And so getting to that level of self-service is something that people frequently go to IAC for, but then find that they don't get it in like the first month or two. Like there's a lot of work you have to do, and there's a lot of tooling you have to kind of put in place to really get that last benefit moving. So like those are the benefits that we're going to see today. And we're going to kind of, as we go through this, we're going to see more of these unlock as we go through like the CI/CD process. But let's go ahead and just kick it off and get to some code. So, but sorry, before we do that, like let's talk about state really quickly. Sorry, we'll talk about state for 1 second. There we go. So when we organize our state, and I'm going to walk you through how we're going to do it for this demo, and what I think is a pretty good default. It's not the best, but when you organize state, like anything else, like there's trade-offs to it. And so, some organizations will just do one, let's say, bucket for all of their state. And what your state is, and we'll look at the state file here in just a second, is essentially it's a database of all of the resources that your Terraform module has created in the cloud and the attributes that it applied to it. And this is what Terraform uses and OpenTofu uses when it does plan and apply to figure out what it needs to change and what it's managing. And so there's a lot of different ways to store your state. By default, it just drops in your local directory. So if you've been following along and you got your week 4 code, if you ls right there, you'll see a terraform.tf state file, right? And even with OpenTofu, it's called a terraform state file so that we can have that compatibility. But that sitting in your local directory is not helpful. It's actually quite dangerous. Because you can't really do collaboration with it. If one of your teammates grabs that same module and tries to manage prod, but they don't have that Terraform state file, they're going to recreate those resources, right? You're probably going to have a lot of contention, conflicts, etc. And so getting that state into a place where everybody can access it consistently with locking requires some effort. And so one of the first things you have to do is figure out how you want to organize this. And this is one of the things that sucks about IAC is you're almost immediately confronted with these decisions that are hard to make if you don't understand how your environment's going to look 3 to 6 months from now, or you're going to find that you're doing a lot of changes to like kind of get it in place and working the way you expect it to. So the different ways people organize state today is some people just do one bucket for all their state, right? So we're going to use S3 to do our state, but you can do Postgres, GCS, Azure blobs, whatever. One bucket's nice, super simple. Only one bucket to worry about, easier backup, cost efficient, but the immediate cons are increased security risk. Anybody that has read access to that bucket can read all of your state files. You can use ACLs to kind of trim it down with your IAM roles, but now you're getting into just an additional maintenance burden in IAM instead of a maintenance burden in the number of buckets that you have. The other one is bucket for a project. So like saying like, hey, this is my project. Maybe it is a series of applications and some databases. This is nice. It gets you really good security and isolation, reduces a lot of the concurrency problems that you might have if you have a bunch of people using the same resource. And it makes it really nice because it kind of fits in your mental model of like how you've laid out your projects. Other ways people do it is a bucket per team. Now this starts to get confusing because like sometimes you end up on multiple teams. So like what bucket is yours, right? That's one that I don't necessarily love. And then there's buckets per environment. So saying like all of our prod stuff is stored in this bucket. All of our staging stuff is stored in this bucket. That's fine. And I see a lot of companies go towards that bucket per environment. I don't personally love it. It's really, really nice if you want tight control over who owns prod. But part of self-service and part of DevOps is you build it, you run it, right? I don't want you to be burdened with all the details of infrastructure as code, but I want you to be able to own it, right? And as soon as I say, this production bucket is owned by, the DevOps team, and so nobody else can write to it. It's like, okay, well, we've just created an interesting place where now developers have to get your approval to run a PR so they can update the state because they might not have access to it. Or if you give them access to it, they have access to all prod now, right? So you get in some really interesting scenarios. And then a bucket per app service. This is another one that I've seen is pretty common. So it's like every single app that you have that's got 3 pieces of infrastructure that it needs, it has its own bucket where it stores its dev, staging, and prod state files. That one's fine too. What you end up with that is real fine-grained control, which is great. Makes it very easy to reason about and manage. Like you kind of have a mono repo of your code and your infrastructure. Makes it really easy if you've got local stack running locally to kind of test your infrastructure as code locally before pushing it up. But it does have a high management overhead. You end up with a ton of buckets. You end up with every service. If you got 300 microservices, it can get pretty overwhelming. So bucket for project is kind of what I like, letting people own that project, own their environments within that project, and store all of their state in there. So with that, we'll go ahead and let's go ahead and start making some state. So I'm going to go ahead and I'll share a link with everybody. So what we did was we set up a repo of some shared modules. And so let me just copy this really quick, throw it over here. I'm going to toss this into the comment section right here. So that's a repo of some shared modules. So I set this repo up already so people didn't have to watch me make a GitHub repo. I know that's super boring. So this is where our shared modules are going to be. And one of those shared modules that we have, if you go into that modules directory, is an OpenTofu state backend. So if you're following along, you can either literally copy that code into your own module, or you can reference it. And so what I'm going to do here is I'm going to reference this module and use it in my code. So I'm just sitting here in a blank directory right now. Make sure I'm in the right directory. Yes, I am. So the first thing I'm going to do is I'm going to make a new directory. So this is going to be, that module is going to make my state, but I need to invoke that module, right? And so what I'm going to do is I'm just going to make a directory here called my state. I'm going to change into it and touch main.tf. And so I've got this main.tf file here. It's blank. And so I'm going to get rid of this, add an extra one there. And so what I'm going to do is I'm going to import that, that state file or that state module that we made so I can create my own state here. So I'll go ahead and do module, enlarge the text. Boom, boom, boom. Whoa, that's too big. Is that good? I'm going to assume that's good until somebody tells me it's too small again. Okay, so let's go ahead and do this. So I'm going to go ahead and reference this state module with a win. There we go. I think it's good. And so if you look at that URL and you actually like follow the path here, let me just go ahead and hop over to this module so I can kind of walk people through this. So this Git repo here, it's got a modules directory where all of our shared modules, you can see this is the DB instance from week 4, AWS instance from week 4, and then this is this new state backend, and it's pretty basic. So you can just copy and paste this, or you can reference it. I'm going to reference it just because we're starting to reuse components, but do as you wish. Now, what you'll notice is this URL right here. This is not what you actually use to source a module. If you do this, Terraform's going to absolutely kind of freak out about it. So it's got this kind of weird syntax that takes out the branches and the blobs and some of the other stuff. And so it ends up kind of looking like, I believe, like this when you want to reference it. So it's just github.com, the organization, the repo, / to kind of skip blob and main, and then the path to this module. And so what I should be able to do now is do a tofu init. You see that it's downloading that module. This is great. So again, this is a little heady. This is a Terraform module that's going to create a state bucket that my other module can use to store its state. Everyone follow? I hope so. That's a bit of a mind splatter there. So this will go ahead and download. And the first thing I'm going to do is I'm going to do a tofu plan and see how this module works. So let's just take a second here. There we go. So we'll go ahead and do a tofu plan. And what we'll probably see is, oh, we need a name prefix. So there's a variable on this module that we need to set. So kind of like we've done in most of our sessions so far, us at MassDriver, we like to use a name prefix for all of our modules instead of letting people name each resource. So if you're following along, you can either hard code a value right here of what you want to name your bucket, or you could take a name prefix itself on this module, right? So let's just go ahead and do that real quick. Type equals string, and now I should be able to tofu plan this. And it's going to ask me, and so I'm just going to say foobar. Now I've already made this bucket. So what I'm going to do is I'm actually just going to bring my state in so that it understands that this bucket's created. But if you're following along right now, you could just type in the name of the S3 bucket that you want, and it will create it. And what you'll see there is it takes that name prefix, how this module works behind the scenes. It takes that name prefix. It has an infix here of OpenTofu state. So this is me as the operator kind of encoding some of our policies in. I'm saying, okay, this is our naming convention for this resource. It's the name prefix you gave it, and then the explicit resource types, the state and the locks. And then I throw a random suffix on there. This is something that we tend to do just to avoid uniqueness problems in the cloud when you have resource IDs. Very easy to accidentally do with a bucket since they all share the same namespace across all orgs. Not as necessary when making things like Dynamo tables, but I like to be consistent and just kind of have that on there. It also makes it really easy if you need to make another version of that in the future. You can give it the same name and it'll end up with a suffix, so you don't end up with like a prod2, which you always end up having in an organization at scale. So we got that there. Now, like I said, I'm going to bring in my state file here just so I don't recreate this. But what we could do if you're following on locally is you do name prefix equals foo, and it should give you a plan and you should be able to apply it. So I'm going to just go ahead and copy my state file here really quick. So I believe this is at workspace MassDriver, OpenTofu foundations, week 5 code, my state, Terraform state. Okay, so now I'm going to go ahead and do a tofu plan again. And so what I should see is it wants to change this bucket. Again, I pre-made this. You can see that earlier I already gave it like a name, OpenTofu Foundation. So I'm just going to go the same route here. So if you're following along, then you should have this plan ready to create this bucket. You can see here, this is pretty straightforward. Now, one of the things I like to do is, and I did this in a very small way here. I like to make my modules usable for somebody who's not familiar with the thing, right? And so sometimes I'll do this as full runbooks, taking in things like the ports and addresses of their database and give them commands that they can run to like troubleshoot. In this case, what I'm doing is I'm actually creating an output here called usage on that main module. And if I do this here, what is it? State.usage. State.usage. Is it module state.usage? Okay, so now if I run this, okay, I have no changes. I'm going to just go ahead and apply this. And so you can see the output here. And what's kind of cool about this is if you have developers that are creating their own state buckets and you've got a module like this, you can actually have, your output give them the configuration of how they can go use this, right? And so now I can copy this block, I can throw it into my WordPress module and start storing my WordPress's state in this bucket. So that's all cool. Now, what does this create under the hood? So we created a DynamoDB table and an S3 bucket. So the S3 bucket is where all of our state's going to be stored. What is this DynamoDB table for? In AWS, the DynamoDB table is used to lock the database. So very similar to using like MySQL or Postgres in an application that's doing like a lot of transactional processing. You need to lock rows so that people aren't, overriding and that you've got like your changes in order, right? Terraform and OpenTofu use this Dynamo table to do something similar. It'll lock and say, okay, Corey is modifying the state right now. So if Chris is trying to run it, his change is blocked until mine finishes. And that way you don't end up with, diverging state files. So this looks pretty good. I will just go ahead and peek this Terraform state really quick, just so everybody can kind of take a gander of what is inside of one of these things. So we'll look at the Terraform state. This looks kind of ugly. You can pipe it through JQ. It's just JSON. So even though it's a TF state file, it's just a JSON file. You can see it's got a lot of different fields in it, but what I'm looking for right here is resources. And so what's nice is like, you don't generally have to deal with the internals of a state file. OpenTofu has a lot of commands to do things like moving resources around if you're renaming, adding, removing, importing resources. But sometimes it can be necessary, I guess, to actually come in and manage the state file and make changes to it. So it is just JSON. It's something that's machine readable. So just wanted to kind of give everybody a little peek there. And you can also kind of see what keys are in it, pipe it through JQ and just saying keys. So you'll see there's check results, lineage outputs, resources, serial, Terraform version, and version. Yeah, I mean, you can store it however you want. So Terry's asking a question. So there's a lot of different backends for Terraform state. So I don't remember if there's a Mongo one offhand, but I do know there's a Postgres one. And what's really cool with the Postgres one is if you're putting it in the JSON-B field, you can actually do some pretty interesting querying to see like, how many AWS DB instances do I have across every single one of my modules, right? That's one of the real benefits of using a true database behind the scenes or something like this is you can do rich querying if you're building up your own platform in your organization. And you can really build some neat tooling around it. It's a bit more cumbersome with something like S3 because you have to pull all the blobs in. But I'm not positive if there's a MongoDB, but there's definitely Postgres. There's HTTP backends. There's, I think, about 15 or so backends for Terraform and OpenTofu. Great question. Cool. So we got this state. So we have a state file. So what's really funny is my Terraform state bucket is being managed with a state file that is not in the bucket. And so one of the challenges for today, the challenge, like self-directed challenges, will be moving this state file into the bucket so that the bucket, so that the bucket is managing its own state file. But we're not going to do that right now. It's a little heady. It's a fun exercise. But we are going to go ahead and start setting up our WordPress module and then using this state store backend. So what I'm going to go ahead and do is I'm going to change directory back to my root. So I've got one infrastructure module here that's managing my state. I'm going to make a directory here called WordPress, change into here. And this is where I'm going to bring in my WordPress module. So if you've got your week 3 code, or sorry, your week 4 code, you can just copy that right into this directory. Or if you don't have week 4 code, you can git clone right now and then just kind of pull that code in. So I'm going to copy all of mine here. Foundations, week 5, code, WordPress. That's what I'm looking for right here. Sweet. This is great. So I'll go back over here now. You can see I've got the shared modules, and then I've got my walkthrough here. So I've got this Terraform state command, or this Terraform state file here right now on my disk. This environment's already been applied. So I've already built out this week 4 infrastructure from last week. I still have it here. What I want to do is just kind of show you what we've got in case you haven't followed up on week 4. Let's go ahead and do the wrong main. Bring this over here. And so what you'll see is I've got just the same infrastructure I had last week. It's making my database. It's making my EC2 instance. Now, one thing that I've already plopped in here is Backend S3. So this is kind of that snippet that we saw come from the output of running the other module. So to actually set up and use S3 as the backend, you add a backend field here. And this is where you specify what backend type you want to use. This is where you put Postgres or HTTP or Azure Blobs or GCS or possibly Mongo if it's supported. And then you can either hard code these values here, or you can set them from the CLI. So which one do you want to do? Well, what's kind of unfortunate is today variables aren't supported for setting these values. So if you do a var and reference a variable, you actually can't pass a variable in to set the S3 backend. So you have to do it either by hard coding it or by doing environment variables, initializing it through the CLI. But if you want to just like kind of make it really easy for yourself today, you can take that output and just paste it here. Now, there's a couple of keys here, and I'm going to do mine via the CLI. But there's a couple of keys here I just want to talk through. So one is the bucket. So this is the actual bucket that it's going to put the thing in. This is what came from that other module that we ran. Here's the DynamoDB table that it's going to use for locking. Important note, if you don't put this key here or you don't configure it from the CLI, it won't use locking. That's not great. So make sure you put it here. And then also the regions required. Now, this last field here is the key, and this is where you're actually going to store the state. And so today what we're going to do is we're going to hard code WordPress / Terraform state. When we start getting into workspaces, we'll look at how we can customize this to make it like WordPress / dev.tf state or WordPress / prod.tf state. But today we're just going to kind of hard code it. And so again, you can hard code all these here, or you can do it from the CLI. And doing it from the CLI it's a bit cumbersome. So it is tofu init, and then you'll do backend config equals, and then you can essentially put these expressions in there. So you can say bucket equals / OpenTofu foundations. You can do something like that, right? So I didn't put in the rest of these values, so it's prompting me for them. So I can put in the key here. I can put in DynamoDB table here, region here. And as I walk through this, what's actually going to happen is this gets stored in the .terraform directory. It's like a meta directory of all these resources. So I'll just go ahead and just kind of paste in the rest of these here. Okay, it's missing region and blah, 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 blah. So what I'm going to do is I'm going to go ahead and just drop in the full configuration. Are there any plans? Oh, sorry, I thought I saw another question. So I'm going to go ahead and just drop in my full configuration here. Let me just kind of put it into a CLI, tofu init, backend config. Go ahead and grab this guy. Key is going to be WordPress state. My DynamoDB table. And then US West 2. There we go. Whoops, I didn't put on the Dynamo table on the beginning of that. Sorry about that. Dynamo DB table equals. There we go. You see it's reinitializing the back end. And so what this is going to do is this is actually checking to make sure these resources are there, that it can access this S3 bucket. It's reinitializing my providers. It's saving this configuration into the metadata, saying like, this is how we're going to store it. And then I should be able to migrate my state. So migrating the state is pretty straightforward. There is a tofu init command again, and then you can just say migrate state. So if you don't have to do this if you haven't already deployed this infrastructure. If you're just setting this up from scratch, you can just do tofu init and all those keys there. Now, if I had my Terraform state file locally and I wanted to push it into this S3 store, that's what I'd run tofu init migrate state for. And that will take my state file locally, push it up, and now I should be in the cloud. Tofu plan. No. So first you'll see it does that Terraform TF state file is gone, but I should be able to do a tofu plan now. And even though I don't have that state file there, I should see a plan that makes sense. If I haven't deployed, I should see it wants to create a bunch of stuff. If I have deployed, you can see it's actually reading my state. It's accessing that, and I can see that there's just one little weird shift here, which is just kind of an artifact of user data and launch templates. So at this point in time, you should, if you're following along, have your state being stored in S3 and using Dynamo for doing locking on this table. Sweet. So now let's talk about something very exciting, which is code organization. So we've got this state file, right? Where we're at right now is we have a my state infrastructure module that created a bucket. We took the bucket that was created, we set that up as our backend config for our WordPress infrastructure module, and then we've migrated our state to it, right? So we're great. We're distributed now, or sorry, we're centralized, I guess. That state is on S3. All of my teammates can access it. If we're sitting here running tofu plan, tofu apply, I know that Chris can't destroy my infrastructure because I've got locks around it. It's going to do a Dynamo lock. But what we want to do is actually get this into CI/CD. And so the next big pain here, besides just figuring out how we want to organize our state, is how do we want to organize our infrastructure as code, right? And so far, we've just been throwing everything in like week 5, week 4, et cetera, making a modules directory. But as you start to get to larger orgs, the organization of your code really does start to matter. So we can hop back over here really quick. Choosing the right repository strategy for your team, like it might feel like you're stepping back into the mono repo wars. And there's a lot of people that do go the mono repo route. There's different repo structures and different trade-offs. And like, you really just got to understand your team's topology and where you kind of are in the DevOps maturity model with how you're going to go, with how you organize this stuff. Now, the thing that sucks is reorganizing this after the fact is exhausting and tedious. So it's one of those things that I like to overthink a little bit when I'm getting started on a new project, and maybe even over-engineer, because what takes 5 to 10 to 20 minutes today to set up might take hours to fix in the future, right? And I would honestly rather, I know the project's going to get bigger. I know more people are going to deploy infrastructure. And so I just try to kind of get ahead of that. And so what we'll see is one of the first ones people look at is doing a mono repo. So that is one Git repo, all of my resource level modules, the things that we're composing together, the DB instance, the EC2 instance, those are there. And then I also have my infrastructure modules, which are the ones that I'm actually invoking, where I'm taking those different resource modules and pulling them together. The nice thing with the mono repo is it's simple, single version control. Everybody knows where to go. It's easy to enforce standards across all the services. But as soon as you get to the point where, like, let's say you're an established business running on AWS, MassDriver itself uses 27 AWS services. So that's 27 root mod or resource modules at least. And then we've got 7 or 8 different microservices that power the whole thing. So now I've got 7 or 8 repos, right? And so if that's all in, 7 or 8 application repos. So if all of that IAC is in one Git repo, that's a lot of changes that don't really matter to me, right? So it's difficult to scale. It's tightly coupled, like the codes and the services. You get a lot of CI bottlenecks, right? If you have, your GitHub runners are now running everybody's modules. They're running the linting work on like the shared modules. They're running the plans and applies. for all of your infrastructure modules. It can get messy really quick. It's nice for small teams, side projects, and things like that. But using a mono repo for infrastructure as code is usually, in my opinion, a big smell. Now, I think this is the perfect trade-off, and that is 1 plus n repos. And all those database people out there freaking out. So like, it's an n plus 1. No, in this scenario, it's a 1 plus n. So it's one central module repo of where all your shared modules are, and then a repo per essentially service or application. So what's really nice with this is its discoverability is easy. Everybody knows where to find modules that they can use. They can go to the shared modules. That's what we're doing here, right? We've set the shared modules up. Everybody on the OpenTofu Foundations team knows, hey, if I need modules, I go here. All of them are listed. Hopefully they've got good readmes. You know, they've got linters running. I know the code quality is good. I know the modules work. Great, right? That modularity is nice. Now there are cons to this. You lose semantic versioning of Terraform and OpenTofu modules if they're in a central repo. So the way that the versioning works, and I don't know if you caught this when I did that module, I did ref equals main. The way that versioning works in Terraform and in OpenTofu is it uses git tags to figure out the versioning. And so what sucks about having a central repo is if you tag something 1.0, every single module just got tagged 1.0. So if you have a Kubernetes module and a database module and something is a breaking change to your Kubernetes module and you tag it 2.0, well, there's a 2.0 now of your RDS module. And what's the difference between 2.0 and 1.0? Literally nothing, right? It's like that's the one con is like you lose semantic versioning. And so you have to version either using refs or, refs or SHAs or, you can still use tags. But the thing that gets really weird with the tags is literally the tags apply to every single module. But I honestly think that trade-off's kind of worth it because this gives you the least amount of overhead, but you're kind of trading off semantic versioning for SHAs. And then the final one is M plus N repo. So as a separate Git repo for every single shared module and a separate Git repo for every single infrastructure module. And now these ones are great, high modularity, granular version. You can do that Simver, you can do some pinning. You just have a ton of repos. And so I would say if you go this route and you're using something like GitHub Actions, one of the keys is to absolutely, sorry, I didn't move the screen to the next one. Here we go, M plus N. If you go this route, I would suggest leaning heavily into things like reusable workflows on GitHub Actions. So you can just say, hey, this is my OpenTofu 1.9 workflow. And it has all of your things in it like checkoff and OPA and all that jazz. So that when you make a change, you have to make a change to one shared workflow that gets applied everywhere versus going into 300 different Git repos and updating your YAML. So today we're going to go with the 1 plus N approach. So we've already set up the shared modules. If you want to walk through making your own Git repo for your shared modules and pushing the week 4 AWS DB instance and AWS instance to it, I'd say go for it. If you're following along and just want to use ours, this is a public repo. So feel free to just kind of ref those things. And so what we're going to do is I'm going to walk you through how to set up the GitHub Actions for this. And they're very different between your resource modules. And again, what is a resource module? A resource module is a module that's not invoked. So essentially, it's a module that just has the resource keyword inside of it, no provider definitions. Whereas you have infrastructure modules like our WordPress module that we are invoking and implying, and it has 2 resource modules inside of it, the DB instance and the AWS instance, right? So when I say resource module, I'm essentially meaning shared or this component. When I say infrastructure module, I'm talking about something that's actually producing the infrastructure. The CI stories look very different for both of these modules because one is it's kind of like you're building a shared dependency library in an application, and then another one is your business app, right? And it's kind of the same analogy. So what we're going to look at is I'm just going to go ahead and hop over to these modules, workflows, and kind of talk you through it rather than show you literally typing every single line of YAML. So if you're making your own repo and you want to follow along for the shared modules, if you look in the directory here and then you look at OpenTofu validate, you will see the very first workflow that we have here. And so you'll see that there is no planning, there is no applying, because these are these low-level component modules. There's nothing to plan or apply about them. But what I am worried about is code quality here, right? I am worried that is my tofu code formatted, right? Is it formatted correctly? I don't want to have unformatted code everywhere, right? Is it an actual valid module? Will it compile, right? So like these are the kind of things that I'm checking here. And we kept this one pretty light just because I didn't want to lose everybody in a giant wall. But this is kind of showing you some of the trade-offs and some of the things you're going to start seeing, right? So you can imagine if this from steps down was how you wanted to validate all of your resource modules. If you were doing the M plus N approach, you would have to copy this to every single one of your resource level modules. So now when you start adding in things like tflint and checkoff and OPA, this is getting longer and longer and longer. And you're entering this like CI/CD YAML maintenance hell. One of the things that's nice about this mono repo for the shared modules is I can use something like TJ Actions changed files to say, hey, watch this modules directory. And anytime a module changes, run this set of tooling just for that one module, right? And so now I've got this one workflow that's going to apply to all three of these resources, and it'll only run when that specific module changes, which is pretty nice. Now, if I want to start adding on other tooling here, Terraform docs, tflint, I can just kind of add it to this little workflow right here. I can also break out additional steps if I want. I was just kind of being lazy and throwing it all in here. Your mileage may vary. Your team's going to have very opinionated thoughts on how their CI/CD should work, but this is a really good place to get started. So if you are following along, one of the other challenges I would suggest here is doing maybe Terraform docs to update the READMEs of each one of these modules. There's a Terraform-docs CLI tool that takes all of your vars and documents like how to use the module. So that's one of the challenges I would give for people that are looking to do something after this session. So this is pretty straightforward here. And we're going to keep it here, and we're going to switch over to looking at our actual WordPress module so you guys can see the pains of this thing. So what I'm going to go ahead and do is I'm going to flip back to my code really quick. And so my WordPress module here, if I wanted to go ahead and push this up into GitHub, the story's a bit different. I'm not just formatting and validating. I definitely want to do that. I want to format and validate this code for sure, because this is more Terraform code. But from here, I need to do things like plan, right? It's running an automation now. I can't do a Terraform plan locally. So I want to be able to do this Terraform plan. I also want to be able to apply, etc. And so now this can get pretty cumbersome. And so I'm going to go ahead and pop open this same YAML that we same approach that we did just a minute ago, where we kind of just look at the workflow that's already written. So I've already written one of these workflows and published it to the OpenTofu Foundations repo. I'll drop that link here in case anyone's missing it. And so if you look in here, you'll see that there's a .github workflows. And then inside of here, there is a week5.yaml. And so I would normally name this something like OpenTofu plan for like my plan, and OpenTofu apply for my apply. But since this is kind of this repo of a bunch of different tutorials, I just named it for the week, because we're going to see week 6 and week 7 are going to have different CI pipelines as we kind of adjust this going forward. And so you'll see right here, one of the things I'm doing is I'm just kind of filtering this down just to run this one workflow on specifically if my WordPress module changes. And so a couple of the things that you'll start to run into with this is when you get into automation, you can run, and this actually hit me last night. I had to call my co-founder and I'm like, hey, help me troubleshoot this workflow pipeline. It's hung. And so one of the first things you'll catch is if you don't put your TF vars in, Terraform and OpenTofu prompt you for them. And so when you throw it into CI the first time and your vars aren't there, your GitHub workers just hang forever. So one thing to always kind of remember to set when you're setting up automation, where you're actually doing a plan and apply, is these two environment variables. And they both start with TF because, again, like OpenTofu's goal is to be backwards compatible with Terraform. And so we want to make sure that we work with all the configuration that is there. So there's two here. There's TF and automation, and then TF input. So TF and automation lets the OpenTofu binary know that it's running an automation pipeline, and it'll skip output messages like, hey, make sure you run this command next, because a human's not running it. TF input just is kind of like setting the interactivity to none. So instead of prompting, it'll just fail and say the variable's missing, right? So you don't get these hangups. So now when we start to set up the rest of this, like this is where, again, like your team's CI/CD may look very different than this, but I'm going to try to get to like the core components and then talk about some of the different tools that you can use here. So one of the first things you'll need to do is authenticate to whatever backend you're using. And so I just went with a pretty basic secret, key and secret. I know that AWS is probably revoking my certification at this point in time for just mentioning it, but honestly, it's the easiest way to get started. I would suggest in production using OIDC. There's actually a really great document that AWS publishes on how to do, let me just find it here. I think I have the link right here. AWS makes some, post the link right there, and I'll show it right here. So AWS does some, makes some of their own GitHub actions, and that's what I'm using here. But they've got a really great doc on like everything you need to do if you want to use OIDC or role assumption. So I would definitely suggest doing that in production. But today I'm just kind of using an access key and secret to set everything up. Set my region here. Again, this is the authentication region for AWS. This isn't necessarily the region that you're going to be applying stuff in. I've got an official OpenTofu GitHub action that sets up OpenTofu and installs it. And then from here, this is where it kind of gets into how you want your workflow to work. So the first thing I do is run format and actually continue. If it fails, we'll see why in a second. The next thing I do is I initialize my state. So this is easy. And like, again, I've hard coded this here. But in a real production system, what you'll probably want to do is probably 2 levels of interpolation of environment variables here. One is where these state stores are. That's probably going to be something you don't want to hard code into your YAML, right? Like you might have different ones for different environments. And then the other one is your key. And so we're hard coding this now. When we get into workspaces, we'll show how to variabilize this a bit, but this is a really great way to just kind of initialize the back end. And then I'm going to run validate right afterwards to make sure the module is solid, so it's able to initialize it, download all the providers, configure the state backend, validate that this module is good. It can access those 2 other modules that I have in my shared repo, and then it's going to run a plan. And you can see on the plan, I actually do continue on error as well. And so what you get with this is pretty much a decent pass on this set of resources. It validates that it's good, it formats it, initializes it, even runs a plan. Now, I wouldn't stop here for production. From here, like you have to start looking at tools like Checkov, OPA, TF-scan, Infracost. There's a ton of different tools that you can kind of bring in to make this pipeline a bit more resilient and a bit more informative, making sure that you're not breaking policies, you're staying within budgets and whatnot. So there's a ton of other steps that you can kind of add in here. And then the final step that I have here is essentially just using the GitHub scripts action to post a comment back. So what's really cool is once you have this set up, if I hop over here to my my PR, where I have this initial import, you'll see, sorry, it's the GitHub action. You'll see that I can kind of come through here. Am I on the right? Nope, I'm in the shared modules. Sorry about that. Let me hop over here. I'm in the wrong repo. So that's part of the problem. You start to get to a lot of repos, stuff gets really confusing, right? So if I click on actions here, I should see I've got, successful action here. If I look at the OpenTofu plan, you can see it went through init, downloaded all those modules, same things we're seeing at the CLI. It ran through validate, make sure everything looks good. It ran a tofu plan. You see my plan, it's got that same weird artifact of user data. But now what's cool is if I hop over to pull requests and I look at the setup. So this was me actually doing the pull request on integrating this back into the OpenTofu Foundation's workshop. You'll see that it posts a comment and I can see that format and style was good. Initialization worked. It ran validation. My config was valid. There was no error messages. The reason I do continue on error is so that it processes that entire pipeline, and then I can take the error and I can publish it back into this block. So I can see, oh, okay, that's what failed. And then the final part here is it publishes back the comment. So this is nice. Like we're starting to unlock some of that collaboration that they talk about in IAC, right? But this is coming from the CI/CD system. So to flip back to kind of where we are and the benefits of IAC, this is where we kind of ended up, right? So by bringing in these 2 pipelines and just kind of reorganizing our code, setting up our state, we went from 3 of these features and 2 walls of YAML we've unlocked a lot more of these, right? So, what's changed? Like documentation's still, like I can see it in a README, but like, how do I know how my overall architecture works? I've got collaboration. I can integrate with these PRs to run and share plans for approval. That's great. Audit trails, I can pretty much look at merged PRs, can act as an audit trail. Is it a great audit trail? Are your auditors going to be happy about it? Probably not. It gets a little difficult to navigate across a bunch of Git repos and infrastructure modules, right? So like if I'm saying Git is my audit trail, then, and I make a change to my WordPress module, but somebody changed that DB instance module to, I don't know, use the HTTP provider to send the password to 4chan, right? Like, how do I find that in the audit trail, right? It's not the audit trail of my app. It's the audit trail of right? Like it's your software supply chain, right? So you do have audit trails. They're a bit cumbersome in VCS to go through, but you can. We unlocked rollbacks, right? So now we can essentially revert a PR to rollback. Now, I will say it suffers the same problem because you have a lot of repos. Like, what does a rollback mean, right? And just because you change a config back in infrastructure as code doesn't mean it actually rolled back, right? Like you could change a config back, but if you rolled forward and it deleted the database because you touched a field that caused a recreate, rolling back is not going to restore that database, right? It'll get you to the same configuration, not necessarily in the same data plane. So it's kind of important to kind of note what that means by rollback. We've unlocked change history, which is great. We've unlocked automation, which is great. Scalability, we've kind of unlocked. So like code repo organization is great as like a baseline for adoption, figuring out how you want to do it. But module discovery is still tough. In this scenario where we went with one central repository and a repository per service, it was easy. I knew where to go. But if I had a module for literally, or a repo for literally every single module, it becomes very hard for me to figure out like, where's Postgres? I have to go to GitHub. I have to search for Postgres, figure out which one of those modules is the Terraform module. Then I have to go back to my code and reference it, right? So like there's still some pains there, still a little cumbersome. We haven't unlocked security and compliance yet. We can start throwing in additional tools into our YAML wall to add things like checkoff, but we're not quite there yet. We have the ability to, but it still requires more effort on our part. And I think the thing that we just completely still miss until you get into an infrastructure automation platform, which is what we'll look at here in just a second, is self-service, right? As a developer, there's still an extreme burden to using these modules, right? We whiz through this. We are copying these YAML walls, but if we weren't in a workshop where we've got, we're going to have a markdown file describing how to do it, it's now up to you as a developer to figure out how to self-serve this stuff. So I got to go through the discoverability problem. I have to go to GitHub. I have to go to our org. I have to search for the module that I want. I found it. Hopefully my ops team ran Terraform docs to describe how to use it. Now I got to go back to my repo, touch a main TF. I got to reference that module, but just referencing that module alone doesn't make it work. I got to copy a CI/CD pipeline to a plan and apply it, right? Okay, great. I copy that, right? So there's a lot that still goes into the self-service of this because there's a lot of copying and pasting. And every time you're doing this, you're kind of expanding your maintenance sprawl. Somebody's got to maintain those CI/CD pipelines. And that's why I said earlier, I'd really try to lean into reusable workflows in something like GitHub Actions. So it makes it very easy to be able to just say, hey, just grab my org/OpenTofu plan and drop it into your infrastructure module developers. And they only have one tiny little wall of YAML to copy. And if you change it at the source of that reusable GitHub action, it updates everywhere, which is pretty nice, right? So, but we've unlocked a lot of the functionality. So what I'd love to do now, I know we've only got about 5 minutes left, is show you how this works in MassDriver. And so what I'm going to do is I'm going to switch back over here really quick. I'm going to pause for any questions. I see a couple of questions here. When using GitLab, GitHub, or other CI/CD tools running Tofu, will it pull down the latest providers? Is there a way to have persistent provider storage and only have providers? Yeah, so you can cache all that stuff definitely on GitHub, GitLab, and other CI/CDs. But it is like an exercise in doing CI/CD YAML hell. So you can use things like caching and whatnot. You definitely can. And I'd suggest it because some of those providers are massive. I think the AWS one's like 500 megabytes or something like that. Great question, Terry. Thank you. So let's go ahead. And what we're going to do is, so with MassDriver, one of the things that changes a bit is you don't have infrastructure modules anymore. You have resource modules. And so what I'm going to do is I'm going to show MassDriver, and then I'm going to come back to our code and see how we do it. So, when we're kind of copying and pasting all this stuff around, we have our shared modules. And in MassDriver, those kind of manifest in this catalog over here. So all of the modules that my team has published show up over here. This is our sandbox environment. So we got a lot of goofy stuff here. And then instead of developers finding it in Git and then making a main TF and then referencing it and then copying CI/CD, et cetera, we kind of shift the way you think about Terraform modules and OpenTofu modules, Helm charts. We support any CI/CD tool. And what we try to do is make you think about those modules as a functional piece of software in and of itself. What do I mean by that? So things like being able to ship runbooks with the module. So one of the things that MassDriver supports is like being able to just toss in a markdown file alongside your code with runbooks describing how the thing's going to work, right? Things that are going to push that self-service more towards those engineers. Screen is really small again. Let me go ahead. Let me see what this looks like blowing this up. Okay. Here, I'll zoom this in a bit too. There we go. Harder to see the whole canvas. And so what's interesting about the way MassDriver works is what we're seeing here on this canvas is a bunch of resource modules. I've got a VPC module. I've got an EKS cluster. I've got a Postgres module. These are all in OpenTofu. And then I have a Helm chart. Uh-oh, different IAC tool. And so what these are is these are resource level modules. But when I put them on my canvas and start drawing them together, MassDriver is creating your infrastructure module behind the scenes. So one of the nice things about using this is when you're trying to scale IAC adoption across your org, to you as an operations engineer, this just feels like any other infrastructure automation tool. I write some Terraform, I publish it, right? To your engineers, they're able to get all of your IAC, but they don't have to touch Terraform at all. They don't have to touch CI. They don't have to touch main.tf files. They literally just diagram. And so what happens is as you start to diagram, here's our MariaDB instance. I'll show you the code here in just a second for making this show up here. I can just come over here. If I want another MariaDB, I can say MariaDB. I need 2 MariaDB instances for my application for whatever reason. I drop it on. I say database 2. You can see that it starts managing the naming convention. This will end up being used as the name prefix. I can add it to Canvas. And what I effectively just did was to a main.tf file, I just added module, Maria, source, and copied the CI. So the way MassDriver works is it works from the module's perspective. You put in the tooling that you want with that module, you push it into the platform, and then when you execute that module, your entire stack of tooling executes. And so what I want to do is I'm going to take this one off the canvas real quick just so I don't confuse myself. And then what I'll do is I'm going to show you how I got this here and like what changes a bit about our modules. So I'm going to hop back over to this DB instance. So I'm looking at this DB instance here. And again, like this was just, git co main. Let me switch back to main. Where am I at? Okay. Apparently I was halfway through a commit. So let's, that's fun. Hopefully we're in a good spot. So I was going to show you how to generate one of these, but I already generated it. So what happened is when I generated it, it took the code that was sitting in this directory as main TF, et cetera, and it shifted it down into the source directory. Now, why do we do that? This is kind of a power feature of MassDriver. MassDriver not only supports putting multiple resources on the canvas, but it actually allows you to put multiple resource modules into the same, what we call a bundle. And so what this lets you do is it lets you invoke different IAC tools in the same pipeline. And this is necessary sometimes. Like when you start looking at Helm charts, I need to run Terraform and I need to run Helm. Why? Terraform makes the IAM role. Helm deploys my application. And so if this was deploying my WordPress application on Kubernetes, you might see that I might have 2 directories of source code, one for the Helm chart, one for the IAC. So it pushes this down, and then it creates a couple of configuration files. A lot of this stuff you kind of ignore. But the main one here is this MassDriver YAML. And so this is a real, what's the best way to put this? This is a power tool for really customizing how MassDriver works. Almost everything about MassDriver can be changed from the point of view of a module, which is pretty wild. So I'm going to peek this file real quick. It is a lot of YAML. You can add as much or as little to this thing as you want, but what you'll see is all of the environment variables that, all the variables that I had defined in Terraform got added here. And so what this allows you to do is it allows you to kind of crawl, walk, run. You can just start with Terraform. And if I hop over here, Terraform or OpenTofu, and I look at this module, you can see I deployed it here earlier. You can see that all of my TF vars turned into fields on this form. So now as a developer, I can just fill this out, right? One of the challenges you have with CI/CD is, where do you store your TF vars? If we're doing everything as code, we have to put it someplace, right? What happens if that thing has a secret in it? Right. So a lot of times teams will just check in their TF vars. And if they have secrets in them, they'll use something like GitCrypt to encrypt it. Right. But as soon as you're encrypting it, it makes it very hard to do collaboration on that. So what MasterDriver does is it actually takes all those input fields from all those different modules and it makes it into a form. And then as you fill out this form, it turns those into TF vars and Helm values, and it pushes those down into the modules, which is pretty cool. Now, what I want to show here is like, this YAML file allows you to really just customize the hell out of the UI. And again, this is from the point of view of each one of these modules. So I know we're over on time. Again, this is recorded, so I want to be respectful of time because I know ops people have a ton of shit to do. If you got to bail, I'm not going to be offended. We're probably only going to spend like 5 more minutes here, so I'd love it if you can stick around. But it will be recorded, so like if you got to run, or you got a project manager who wants you to sit in a meeting, I understand the pain. But I also want to show you this because I think it's sweet. So we're going to go ahead and hop back over to this MasterDriver YAML, and I want to kind of show you like some of the functionality you can get by leaning into an infrastructure automation platform. So the first thing is like, it's funny, is like, this is ClickOps. It's ClickOps with IAC under the hood, right? And what's nice about this is your developers want to do ClickOps. They're already doing it. That's why you buy in Drift tools. You gave them Terraform and they went into the AWS console anyway, right? But what's also nice about this is the discoverability and maintenance burden on you as an ops person starts to go away a bit. I can shift things like runbooks. We'll see metrics here in a second. But when I'm letting developers run their own Terraform, I don't know what they're making anymore. And sure, I can use things like the AWS CLI to list all tags or all resources by tags. But what if they didn't tag it, right? And so you end up in this just wall of JSON coming back from the AWS CLI, trying to figure out who owns what and where. What's nice about MasterDriver is as they're connecting all these infrastructure modules together, they're literally diagramming them. And you can do things like cross projects in MasterDriver. Right now, we're in a project called Demo, and we've got 2 Terraform workspaces or OpenTofu workspaces, staging and test. You can actually share resources across projects, link them together. You can share resources across the IAC tools. And so it's really nice is when you come in here as an ops person or SRE and you're paged at 2 in the morning and you've been letting your developers self-serve, instead of you hunting around 300 Terraform modules and PRs trying to figure out what they did, I can come in here and go, oh, okay, their application's crashing. I can see that they're using this Postgres module. Nothing's changed about the application in a week, but maybe this Postgres resource got updated today. Right? A lot of times the reason your application goes down is maybe somebody changed something about the database, right? Maybe they changed the way the connection pooling works, or maybe they changed the IAM policy. And you can come in here really quick and see the history of every single change to this database, right? So helping SREs in the middle of the night lower that mean time to resolution because they can quickly see everything that the developers are using together. And they can come in here and they can do things like say, okay, well, what did Corey change about this? Instead of diffing your Git repo, which has all of your code, 1,000 PRs a day because you're shipping fast. And then there was some Terraform stuff you managed 10 days ago that I'm trying to find that diff. Instead of going through and doing diff surgery, I can just come into something like MasterDriver and I can say, okay, well, what did they change? And I can see, okay, well, Corey scaled this from 1 to 4 CPUs to 0.5 to 1. Well, if their application's down, maybe that's the problem. Right. And from here, I can just go right back to doing something like a rollback, right? And roll back that configuration. So we're trying to make it where developers are able to get that self-service without getting the burden of ops. And at the same time, not burdening ops with the disarray of developers managing their own infrastructure. And that's what we really see as like the 2 things that just stranglehold companies in working through adoption. So what I'm going to do is I want to show you like how you can kind of crawl, walk, run. So what we did so far is I just ran a single CLI. You can see me here going through some push and pray stuff earlier. I had something dumb messed up and didn't catch it for a while. But what I want to do is show you how you can kind of use that MasterDriver YAML file to essentially customize this platform that you're giving your developers, right? So this is great. I'm looking at this and I'm like, okay, allocated storage, DB name, engine. You can kind of see that the names are all in alphabetical order, not necessarily the way a developer might think through these things. And so if I hop back over here, you can actually control the UI. And so you can do things like the UI order. Right now I have it just set to asterisk, which is, any order you want. But I could do something like password and then everything else. And you know what I also noticed is that password was stored in plain text. Oh, there's the password for my database. That's not good. And so what I can do is I can come in here. I can make that change really quick. I'm going to move this over here just so we can see both of these side by side. And then I'm going to do mass bundle publish. And you can incorporate this into your CI as well. That publish this module. And now if I refresh this page, what I should see is password moved to the top, and now it's a masked field, right? And so you have a lot of controls over how the UI works and what you're presenting to your developers, but it doesn't really end there. Like that's just like kind of the basics. I'm going to remove this module really quick, and I'm going to re-add it. So I'm going to do Mariah DB. Look, okay, as a developer, instead of me going to GitHub and hunting around, I can just type in Mariah, see all the modules that are accessible to me. I'll call this my, just call this DB, right? It drops this back on the canvas. And so one of the things that you first kind of see the first time, right? So now this isn't configured. I deleted it, so the TF bars are gone. As a developer, like, okay, this is a lot. This might be a lot for me. This is a DB instance too. This isn't an RDS cluster with zones and all sorts of stuff. You can imagine how this form gets really complicated when you start to get to more complicated pieces of infrastructure. This is a pretty basic one, but even though this is pretty basic, like I might not know what instance class to put here. I might even not know what they are, right? And so you can kind of start tapping into this YAML file bit by bit, making this a little better. First off, maybe I want to do something like throw in some validation. And this is all based on JSON schema. So if you're familiar with, OpenAPI and Kubernetes, how it works under the hood for its JSON schema, it's the same JSON schema. You can add rich validation and things. So now it's going to validate that the password is greater than 8 characters. Publish this back in. And again, I'm kind of like starting to enforce my policies on my developers through the point of view of this one module. So now I come back in here, refresh this. I'm going to set my password to just 3 characters. I'm going to hit save, and you'll see that it tells me I'm missing this field. And I could go ahead and say, let's call this database, right? Give it a name prefix, hit save again, tells me I need a username, right? So it's telling me the fields that are required. And then you can see up here, once it went through all the required ones, said, hey, this one's got to be 8 characters because we just added that validation. So what's really cool about this is it's JSON schema-based validation. It means all the stuff you can do with JSON schema validation, you can do once across all of your IAC. So you'll see with validation in Terraform and OpenTofu, it's fairly limited. With this, you can do validation across fields. You can do things like enums, right? So like coming back to that instance class, like I might not know what the instance classes are. So I can do something like dbt3 micro, db.t3 large. I can publish this back in. And now when I refresh this UI, I'm not going to save that password. When I come back into this UI, what I'll see is now instance class is a drop down, right? And so I can say things like, hey, I want to control what instance types my developers are using. Not only which ones can they select. Maybe we don't want to use burstable at all, right? So I not only can I control the ones they select, but I can also give them inputs, right? Which is up to them to go search, right? The number of times I've seen developers put in t3.large instead of db.t3.large, numerous times. I've seen plenty of ops people do it, right? So you can start to give people more guidance and guardrails around how they're going to use this thing, instead of just throwing a bag of Terraform at them and saying, hey, good luck with that. Ping me on Slack if you need help, which you're going to, right? And we can kind of keep going from there. We get a lot of functionality in this YAML file. So one of the other things I want to do is, again, I'm a developer. I might not know what to set these as. So you can come in here and you can set some examples. I can republish this into the platform. And now what will happen is the first time I go to deploy something, it'll give me some configuration options. So if I'm a developer and I'm like, hey, I don't know all this zone stuff. I don't know half these things. This is my development environment. Like, just give me one. And you can grab a development preset. And again, this is all Terraform behind the hood. So if you don't want to expose the password to people to let them put it in there, you can automatically generate a password, or you can use SSM and secrets management to do password rotation, right? So, but you have this ability to start enforcing this without forcing developers to use the actual underlying IAC directly. So that's cool. I got these options now. I went ahead and I picked development. I can get going. I can deploy this thing really quick, but let's see what else we can kind of do here. So That's all fun. We've got some presets. We can even do things like nice names and descriptions. So you can see that, the store thing right here, it's very, very developer, or it's very like codish. It's allocated storage. We could do something like allocated storage. You could even say read more here, right? I'm just going to put pound symbol. I don't have an actual web page to send people to. Actually, let's do it. Let's send example.com. Right? I can publish this back in. And what you're starting to get is you're getting the ability to guide your developers through how to do this stuff without them constantly pinging you or you writing it in a doc that they have to reference. And instead, you're literally just getting the interface updated by making some changes to this config file. So I come in here and you see allocated storage has got a nice name and it's got this nice description with a link to example.com, right? So that's fine and dandy. What I'm going to do is I'm going to go ahead and I'm going to deploy this bad boy and hopefully it works. Otherwise, that'll be embarrassing. Let's go ahead and hit deploy. So you can see MassDriver takes care of all the actual provisioning. It'll respect your state store. So if you put a state store in place, it'll use it. If you don't have a state file, what we actually do is we have our own state storage system. We'll just automatically assign it and use it, which is really nice. So like you can essentially lower the amount of code that you have in your modules as well, because you don't have to put the state storage in there all the time if you don't want to use it. And we're going to release a deep dive on how our state storage engine works, because we've gone kind of above and beyond to add some security to our state storage that a lot of state storage don't have. So this is going to provision. This takes like 3 or 4 minutes. What I want to do in the meantime is show you like how you can continue to like push self-service and push ease of use of these infrastructure modules while this thing's provisioning. You can see it's applying my OPA rules. That's cool. You see this right here? It's applying my OPA rules. As a developer, I didn't copy any OPA rules. I don't even know what the hell OPA is. I don't care. As a developer, I don't give a shit what OPA is, but you as the ops person do, right? And like, that's what matters. That's what I was able to do. I was able to ship that functionality in this bundle out. Nobody had to copy anything. And if I change my policies for how that module should work, and publish it, every single invocation of that is going to get those updated policies. I don't have to go hunt down 400 Git workflows and update them all. So that's going to take a little bit to run. Hopefully it doesn't fail, because that would be embarrassing. What I want to do is show these little line things. And a lot of people, when we get customers come in, they see the lines and like, oh, that's cute, it's decoration. It's not. It's like the power tool of MassDriver. So what this is it's our artifact system, and it's very similar to Terraform outputs or OpenTofu outputs, except for there's a couple of things different. First off, it's opt-in, right? So one of the problems with Terraform outputs is everything you put in there is there. And a lot of times people put outputs there so you can see them. And sometimes people put outputs there because they need those outputs to put as an input to another module, right? And so you have this mixed concern. And so what we have in MassDriver is this concept called artifacts, and they're opt-in. So they're saying, hey, this is something that the rest of the canvas may need to know about. And it's not necessarily something a human needs to see. And so what's cool is if I come back over here, I grab this module, I'm looking in the source directory, we've got this artifacts file, and I've already commented this out. And so this is a lot to look at, and I'll kind of explain what this is. So again, this is opt-in. Again, you can kind of think of it like an output. And what we're saying is we're going to publish this artifact into the system. And what this does is a couple of things. One, it actually lets you have strict contracts between your infrastructure as code modules. So if I come down here, you'll see as I've already added this, I'll just uncomment it really quick. This is the artifacts that my bundle is going to produce. And so that means is this is something, I like to think of these bundles as black boxes to developers. Developers don't care what AWS resources are in there. What they care about is MySQL coming out, right? That's what they want is MySQL. And so what I'm saying is this thing produces a MySQL. Now, what's cool about this is you can see that it's MassDriver/MySQL. If you can make your own type system in MassDriver, you can publish it in there, and your company can actually start to standardize on what your modules produce, whether that's Terraform, OpenTofu, Bicep by Azure, or Helm. You can say, hey, my things produce something that can be consumed by other modules. And so this is how internally at MassDriver we define ours. We do extremely rich definition of these. But you can see that, in this case, we're passing username, password, we're passing all the connection details, we're passing security information. And so what's cool about this is the way that we design our modules is applications that are expecting MySQL know that they're going to get all of this information. And this is managed by the MassDriver bundle build tool. This automatically gets set up and you just kind of tie it into your Helm or whatever. And so what's nice is the way that we currently run ours, so MassDriver runs on MassDriver, is when I connect this MySQL to, let's say, this chat application that I had on my canvas, it will automatically do the IAM binding. The chat application creates a role. This is pushing forward network policies, authentication. It can push IAM policies forward. And when that application that's receiving it sees it, it goes, oh, I'm receiving policies and I have a role. I'll do all the IAM binding on that role for you. Developers didn't have to think about it. Developers didn't have to ask you to do it. This is something that you coded into your Terraform as a baseline for how your company operates. You say, hey, if MySQL is being used by a developer, give them principle of least privilege by drawing lines. And by connecting those lines, they're getting new policies. You can also push the authentication information across as well. So what I'll do now is that should be running. I'm going to go ahead and republish this module. And so now what it's going to want to do is it's going to want to connect to other things and produce these artifacts. And so if I come back here, you can see this database did provision. I'm going to refresh really quick. And what you'll see is something about this module changed. And that is that it got this little tiny dot on the outside. So that is the output that it's producing. So it's this black box it's running some Terraform is now producing a MySQL connection. It's going to push credentials across. It's going to push policies across. It's going to push security groups across. And if I look at this module real quick, I can come in here. I can see if I click on artifacts, you can see that I produced a MySQL authentication. Sorry, I need to run it one more time. We just published it. So I'll go ahead and run this one more time because it's Terraform in and of itself, right? So let me just go ahead and redeploy this, and this should now make this artifact. Now, while this is running, what I'm going to do is I'm going to update this chat application here. So this thing is currently using Postgres. I'm going to add a requirement to that application. So you can put these MassDriver YAML files. Thanks, Nico. These MassDriver YAML files, you can also put it in your applications, like right alongside Helm chart. And what's nice now is that those contracts that we've kind of started to define as ops people, this is what a network looks like. This is what MySQL looks like. This is what connecting and deploying to Kubernetes looks like. Now, from the application perspective, instead of me trying to understand what all that means, I can just say, I depend on foocorp/MySQL. And the rest is handled for me. And so what I'm going to do is I'm going to go ahead and add MySQL support to this application really quick. Let me find, I closed my other editor. Okay, let me open this really quick. Application examples, Kate's demo chat. Yeah. And what I'm going to do is you can see that I've already got this in here. So very similar to, there we go. Okay, and now I'm going to go ahead and republish this. So that was already added. So what I had to do is I just say I require MariahDB, and here is the type that I'm expecting from MariahDB. So like your developers now, instead of going and learning about all this infrastructure, they can just say, hey, this is a thing that I require. And this type system, what's nice about it is it actually enforces the connections. If you try to connect two things, if I try to connect a MariahDB to a MySQL or a Postgres to a MySQL, MassDriver will actually reject those connections, where to Terraform and Helm, they aren't real types. They're just strings, right? And so, hey, you give me a username and password, I'm going to try to use it, but my application has no idea what MySQL is, right? And so you can actually stop breakages from happening by having these type contracts between things that say, hey, this is explicitly what I need. So this is already set up. I'm just going to go ahead and publish it. So let me go ahead and just change this same repo really quick. So this is publishing that application. It's just giving me a warning because I've got something deprecated there. I'll switch back to where I was. And now when I come back to this canvas, what I should see is, really wants to save my password. You can see that it added a new requirement on this application. So you can see that this is now requiring MySQL. And if I click on it to drag, you can see that it's detected a MySQL resource. I can add it. That's pretty cool. So one of the other discoverability things that I can do here, though, is like, let's say I chop this off really quick. I know that I need MySQL. I saw it there. If I didn't have MySQL on my canvas already, what I could do is I could come here and I could see that, hey, I've got this requirement for MariahDB, but I don't currently have one. I can click on View Resource Recommendations, and what it'll do is it'll show me different ways that I can get MySQL. So the first one is it says, hey, you have MySQL running in your current environment. Do you want to use that one? Maybe I do, maybe I don't, right? I have plenty of applications where I have 2 Postgres databases, right? Mass driver itself has a Postgres database for its data and a Postgres database for Kratos, a tool that we use for authentication, right? And so I can either connect to that database or I can add a new one. And you can see that, again, this is our sandbox. So we publish a lot of modules here, but we've got 7 different modules that can provide MySQL. And so I can grab one of those. You can see that it even kind of works cross cloud. Some caveats there. So I can just go ahead and select that one. And you see that it'll draw that connection for me. And so now when I deploy this application, my application doesn't actually use MySQL, but if it did, I would get the policies and network information and the credentials to actually run that, which is pretty cool. So, and then you as an ops person can go and say, okay, well, what are all the instances or what all is using every single module that is produced by AWS RDS MariaDB instance. You can see that you've got 15 invocations of it being used by 25 different apps. Very hard to figure that out just looking at Git and PRs, right? So that's all cool. What I want to do is just show a couple other things here. So there is the history, which I showed earlier. We can kind of go through here and do the diffs. You can look at configurations at specific points in time. One of the other things is like trying to push that self-service to the next level, right? You don't necessarily want developers pinging you every time they want an alarm set up, right? I see this a lot still with SRE teams where it's like, hey, the SRE team, what does the SRE team do? It's like, they create alarms for us. That sucks, right? Like part of you build it, you run it is to start to accept the fact that you have to run these things, right? And maintain them. And so what we try to do is make it where it's easy for developers to get an idea of not just the current real architecture as it stands today, like real living documentation, but also understand the health of that. And so you can do things like where you can see right here, every single metric that is produced by all of the resources inside this module are elevated here. And so I can say, okay, you know what's important to me when I'm looking at this canvas? You can still use Datadog and whatnot, but when you're looking at the canvas, you might say, hey, you know what? Knowing what the average CPU is of this is super helpful. So I'm going to go ahead and watch that, and it'll start streaming in those metrics. You can see it's at about 3% CPU utilization, but also the sum of the database connections is important. Actually, I want to make an alarm on that. If it's ever less than 100, I know that there's probably a problem with my application. Let's go ahead and create an alarm. Now, this is going to almost immediately set off an alarm for me because I'm not actually using it. But you'll see the alarms come through in a minute. But you can come in here and you can quickly start to say, I've got this living documentation. I want to go ahead and annotate my diagram with some metrics as well and some alarms as well. Which is pretty cool. And then the next thing is obviously getting to the guide. So this guide is pretty straightforward, but the way that we write guides internally is we write pretty hefty ones. So we go through our design decisions so people understand what they're getting with it. We put in run books that show like how to run commands with this, right? Really pushing that self-service all the way to the limit. What I want when somebody's using, or when one of my developers is developing on my team is I want them to really build it and run it. Now, I don't want them to be overburdened by all the details of the cloud, but I want them to be able to troubleshoot on their own. I don't want them to feel like they built something and then they have to depend on somebody else. So I want to push out that time for when they tap an SRE or tap an ops person on the shoulder as far as possible. And then one of the other things you might notice, hey, here comes my alert. Hey, the alerts show up right here. So what's pretty cool with this is I would have just gotten a Slack notification or an email. And if I click on that, it'll actually bring me to this canvas, highlight the infrastructure that's failing, and show this alarm. So even just getting to starting my mean time to resolution journey is faster, right? It's not like I got a PagerDuty that took me to a Datadog that I went and looked for some PRs, and I couldn't find anything in the PRs, so I had to look at the modules that they were using. And oh my gosh, the database module changed 3 weeks ago, and it affected all the databases. Like, boom, I'm here ready to look. I don't have to go through 3 different tools. I can see that this database is having a problem. I can see that this application is using it, which is probably affecting this application's availability. But now I can come in here and say, okay, well, what's wrong with this app? What changed? What did Corey change recently, right? And you'll see that I probably didn't change much. So I put this really bad alarm on. But if I had just changed something about the database, maybe the instance class or something like that, maybe that's why I had a connection issue. Right? Maybe I was running some R5 extra large and somebody accidentally changed it to a T3 micro. That'll affect your ability to connect to it, right? So we try to make it where it's easier for people to fully own this infrastructure lifecycle, not just simply be able to deploy things. So that's us in a nutshell. I hope that was pretty cool. Sorry that took a little longer than intended to go through the mass driver part, but yeah, so that's us in a nutshell. And like I said, the rest of the sessions, 6 through 10, are going to be very similar to today. It'll be a lot of talk about OpenTofu. It'll be a lot of talk about like how it works in CI/CD, and then we'll just spend like the last 5 minutes and any time that people want to hang around after the session to kind of talk through like how you can kind of take your infrastructure adoption journey and really move it to that next level of where developers feel like they're getting something like Heroku. They feel like they have a pass, right? That's what they want, right? Every developer on the planet would be using a pass if it wasn't for operations coming along and telling them to use the cloud, right? And that's what we're trying to do, is like get that harmony where developers feel like they can focus on their code and not everything else, but operations also gives them that enablement without giving them a foot gun. So I really appreciate the time, everybody that stuck around. Thank you. I really appreciate that. I thought from the original Reddit post that people were going to be very uninterested in seeing the product. So I really appreciate that people stuck around and looked at this. If you do want to turn these things into bundles, give it a try. If you want a pair on it, like ping me. I'm happy to hop on and like walk through it. I know my co-founders, Chris and Dave, are as well. Would love your feedback. And if you're on a team today where like you're really excited about IAC, but you're like, fuck, the developers, like they don't want to do it, or we're struggling to get them to do it, or it feels like we're doing IAC, but we're doing the hard work and developers really aren't, like that's our sweet spot. And so if we can meet with you and some of your developers and talk about how we can kind of use tooling to kind of facilitate better culture between dev and ops, we'd love that opportunity. So thanks so much. I'll stick around, look for more questions, but I appreciate the time, everybody. Have a great day.